Okay, the last lesson in this module is talking about variable scope. Now, you may already be familiar with the notion of variable scope, but we're going to introduce it again because it's such an important concept. And we're going to do more than just introduce the notion of variable scope. We're going to also incorporate it into those memory models for reasoning about Java code. So by the end of this module, you'll be able to describe the notion of scope and Java's rules for scope, as well as draw those memory models to incorporate scope and reason about code using those memory models. So get out your pencil, get out your piece of paper, make sure you're not driving, and you'll draw these memory models right along with us. So we're starting off with a little warm-up question. I want you to look at this code. This code should look pretty familiar to you by now. And I want you to identify the 6 variables that appear in this code. So pause the video for a second, see if you can find 6 variables in this code. All right, welcome back. Hopefully you found 6 variables. If you didn't, don't worry about it. Here's the 6 variables that I found in this code. Now, you may have also identified that keyword this as a variable. It's not quite a variable. It behaves a little bit like a variable. We'll talk more about that later as we add in scope into our memory models. But here are those 6 variables. There's latitude and longitude, which are the member variables in our simple location class. There's lat_in and lon_in, which are the parameters to our method, to our constructor. And then over in our main method, there's lima, which is our simple location object, and then that tricky one, which is the parameter to the main method, args. So all of these variables are not necessarily created equal. So even though latitude is a variable in this code, if I try to refer to latitude over here in the main method, what do you think is going to happen? So take a minute, take a guess. What happens if I just try to directly access the variable latitude in the main method? So if you tried this, you will have found that it caused an error. If you try to access latitude in this location, in this main method, Java is going to tell you that this variable latitude is not defined here. So this brings us to the idea of scope. The scope of a variable is the area in the code where it's defined to have a particular value. And in this case, in the main method, that variable latitude is not defined at all. It hasn't been declared here. It was declared over in the simple location class. It was one of the member variables. So I can't get at it in main. So let's talk about a few different types of variables and types of scoping rules for those variables. So the first kind of variable we're going to talk about is called a local variable. A local variable is a variable that's declared inside some method. For example, lima is a local variable. And if that variable is declared inside the method, outside of any block like an if statement or a while loop, then that variable can be used and has a particular value that you set it to all the way through that method. So in this case, I can use the variable lima anywhere inside the main method, but not outside the main method. Second kind of variable I want to talk about are parameters. Parameters are those arguments that we pass into methods, and they behave basically just like local variables. You can use them anywhere inside the method, you can change their value if you want to, and essentially they're just like local variables. The third kind of variable are called member variables. Now you're familiar with member variables already. They're those variables that belong to a class rather than being declared locally in any method. They're declared outside any method in the class. And this means that these variables, their scope is actually the entire class itself. So you can refer to latitude and longitude from any method inside this simple location class. So they have kind of a broader scope or a wider array of places where they can be used than those local variables. So that in a nutshell describes scope and a few different kinds of variables. But really what we want to do is be able to reason with this notion of scope. And in order to do that, we're going to go back to our memory models. So here's where you're going to need that pen or that pencil and that piece of paper. We're going to trace through this code. It's only 2 lines of code, and we're going to layer in this notion of scope into our memory model. So we're going to start you off with a simple statement here, which is just a variable declaration and an assignment statement. So you know what to do. You draw the box, you put the value in the box. There you go. There's our variable. It's called lat, and it stores the value -12.0. But now we're going to, as I mentioned, layer in a notion of scope. So this variable doesn't exist just anywhere. It exists inside the scope of the main method. So the way I'm going to denote that in my model is I'm going to draw a box around that variable and label it with the name of the scope that I'm talking about. So I've got a fancy box with some shadows, but in your drawing on your piece of paper, just put a simple box around it, label it with the name of the method, which is main. My next line down, I declare another local variable, lima, inside of the main method as well. So that also goes into the box representing the scope for main. Now things get a little bit interesting because lima is an object type variable. It's going to store a reference to a simple location object. So that simple location object, as we've looked at before, gets created over here in the heap, which is a separate part of memory. So the simple location object gets created, and its two member variables, latitude and longitude, get placed inside the object that gets created on the heap. So that latitude and longitude, they're not inside main scope. They're over there in the scope of the object. So that's how I'm going to denote them in our memory model. But when the constructor gets called, we get some more variables that get instantiated. We get those parameters, lat in and lon in. And they have their own scope, which is local to the constructor for simple location. So I need to draw that scope in together with the variables lat in and lon in. So I've got another scope box for the constructor with the parameters that I've passed in. Those parameters, of course, get their value from the arguments that I passed when I called the constructor. Now I'm going to add one more thing to the scope of the constructor, and that is this keyword this. So we talked about this before. This refers to the calling object, and in any method that's inside the class, we have access to this keyword this, and what this stores is a reference to the object that we just created. So in this case, we see that object over there on the heap. We have our keyword this, whose value is a reference to that newly created object. And I'll put this inside the constructor scope because the constructor has access to this. So now we can go ahead and trace through the rest of the constructor. We see that that first line of the constructor takes the value of lat in, which is inside the constructor scope, and copies that value over into this dot latitude. So we follow the arrow and copy that into the member variable latitude inside the object. Same thing happens with the longitude variable. We just copy the value from lon in over into the object's version of the longitude variable. Now the constructor is over. So what happens to its scope? Well, when a method ends, its scope disappears. So all those local variables, the parameters, any variable that has been declared locally, they disappear, they go away. You could never use them again. They're just gone. And now, as we know, the constructor is over, so we return back to the main method and set lima to have a reference to that newly created object. So that's basically it for adding scope to your memory model diagrams. There's just one more subtlety I want to touch on before we finish off this introduction to scope, and that's the keyword this. So we've been using it, and it's very useful, but it's not strictly required in Java. So I don't have to preface my member variables with a this dot. I don't have to preface calls to methods inside my class with this dot. I can omit this. And Java will work just fine. It will figure out what I'm talking about just fine. And let's take a closer look at how it does that. So if I leave off the keyword this, what Java is going to do is it's first going to say, oh, I see a variable name called latitude. I think that's probably a local variable. So I'm going to look for it inside the scope of the method that I'm currently in, which in this case is the constructor. But in this case, it's not going to find the variable latitude in the constructor. So what it's going to do instead is look over in the object whose basically that was the calling object for this particular method. So it looks over here in the simple location object. Now it finds the variable latitude, and that's the variable that gets changed with this assignment statement. So that's all there is to scope, and we've got some practice problems for you, which we hope you'll enjoy.
Hi, and welcome back to our module on scope. It's time for another one of these concept challenges. Again, the flow for this is you're going to pause, think about the problem yourself, you're going to discuss this if you have other learners around you, you're going to watch the UC San Diego learners tackle the problem, and then you're going to hear our explanation. So the question here is going to involve essentially two classes. You've been working a great deal with simple location, and we're going to keep using this class, and that's the one on the left. We've got a tester class on the right, and that tester class has a main method. It's within this main method where you're going to see a number of things get declared, and then something get printed. The big question is, what gets printed?
Hi, I'm Tanky.
Hi, I'm Peter.
And I'm Joe.
So what actually happens when we go back to our main method and we look at lat gets negative 12.0? Is that going to change Lima's latitude value since that's what we took in as the variable?
Well, I think since we were just working with a primitive data type, then it was just like getting a copy of it, right? It wasn't like doing the whole arrow thing like before. Like we're not pointing to an old object, we're just getting a copy of its data.
All right.
And regarding the scope, I think the double here is just in the main scope, so it won't have any access to the object itself, right? So you change the number here, you just change the number in this scope.
Oh, like locally?
Yeah, just like
Okay.
locally.
All right,
And
so
not the object.
so even when we come back to the main method and we look at lat gets negative 12.0, that's not going to change the latitude in our Lima.
Right.
I see.
They
All
just
right.
have the same name, but like two different access, I think.
Oh, okay. So in the end, when we print out lima.lat, it's going to remain whatever we created it in the first place, which was negative 15.5. All right, cool.
As you saw when the students were discussing, the key to solving this problem is tracing through the code. So what we're going to do is exactly that. Now with our code, we're always going to start with main, as we have in the past, and we're going to start with the very first line in code, which is that double lat equals minus 15.5. So just so we know with all the memory diagrams, I'm going to start by creating a scope in main, and I'm going to declare space for a variable named lat. The first thing I'm going to do then is fill that with minus 15.5. And that does the first line of code. Next step, we're going to create a new variable called lima, right over here. And that's just a reference. Then we call new simple location, pass it a lat, and a minus 77.0. That operation is now going to call the constructor. So let's move to the scope of the constructor. Box this off as the scope of main. Box off the scope of my constructor in simple location. CTOR stands for constructor. And within that scope, I've passed now two parameters. So it has two variables, both lat in and long in. Each of those parameters just are now pre-filled with the values as defined at the time of the call. So lat was minus 15.5. That's this copy by pass by value in Java, so minus 15.5. And long in is going to be minus 77.0. The other piece here was we said new simple location. The act of saying new actually allocates space on the heap. So what I'm going to do down here is create that space on the heap for a simple location object. And that object is going to have the private instance variables lat and long. At this point, we already see that we have a number of cases where we see the variable lat. And that's going to be at the heart of this problem. So let's continue walking through the code. So we're right now in the middle of simple location where we've already passed in these two parameters. And what we're going to do now is actually do this line of code. So this dot lat refers to the object on the heap. This is my simple location object. And it's going to be assigned the value of lat in, which is minus 15.5. So I'm going to copy that value over. The next line of code is going to behave exactly the same way, right? All it's going to do is copy minus 77 into long. Now we finish this constructor, and at the end of any method, as we know, these variables essentially get destroyed. So I'm just going to do a quick line through it to say that our constructor variables are gone, and we're now back in main. So within main, the very next line of code we're going to execute is right down here. It's going to say lat equals minus 12. What lat are we referring to? Well, I'm going to look at my local scope. I have a variable named lat, and I'm going to change it to be minus 12. Now, I've already made one mistake here. And that mistake is, when this constructor finished, it would have returned a pointer to this. And I failed to connect this to the object on the heap. All right, now that's connected properly. We now would have done the change to this to be minus 12. And now we're going to try to print lima.lat. So I'm going to follow my pointer, my reference out to lima, and I'm going to check what value does lat have. Well, the value is minus 15.5. What's going to be printed then is exactly that, minus 15.5. What we see from this, walking through this code, is that as long as you trace through the code, you draw your memory diagrams, you're going to be able to solve this type of problem.
So you've now heard a lot about objects, you've heard a lot about memory models, you've heard a lot about scope, you've worked through some concept challenges, and now we have an opportunity to put it all together. So buckle in, get ready. This is going to be a tricky example, but we're going to get through it together. So what we're going to do here is take the simple location class that you've talked about a lot with Christine, and we're going to change it a bit. So remember that simple location, we want to encode the latitude and the longitude. And so far we've been encoding them as two instance variables. Each of them is a number type, a primitive type double. But now we're going to twist things up a bit, and we're going to define a new class, a different class called array location. And we're still going to want to record the coordinates of that location, but we're going to try to implement this by recording them in an array. So it's an array that we're called coords, and the kind of information that's stored in that array are still going to be doubles. All right, so let's think about how we might define this class array location and then try to use it in the main method. Okay, so for our class definition, we define the instance variable coords of type array that's going to contain doubles, and then we're going to need to define the constructor. And the constructor, when it receives a parameter that's specifying an array that indicates the coordinates, we're going to say this dot coords equals coords. Okay, so that's going to be the definition of our constructor. And then we might go ahead and want to try to use these objects. And so in our main method, you can imagine a situation where we start us off by defining a new array and initializing it to 5.0 and 0.0. And if you look on a map, you'll see that those are roughly the coordinates of Accra in Africa. And so then we might want to create a location and label the variable that's pointing to that object, that array location object, and call it Accra, and say that variable Accra is going to point to a new array location with the coordinates as specified in that previous array. And then we might want to go ahead and get ready to think about a different location. And so we might want to use our coords array and store the value 32.9 in the 0th index and negative 117.2 in that the index 1. And if you recognize those are the coordinates for UC San Diego. And then, just to check that we haven't messed anything up, we might debug our code by printing out the coordinates pointed to by the Accra variable. And so what I'd like to do now is pause, and I want you to, first of all, think through what you think will happen when we do this. And second of all, open up Eclipse, type in this code. Remember that your file name is going to have to be arraylocation.java to match with a class name. And see what happens, and see if you can explain what happens. And when we come back together, we'll work through the memory models and figure out together what happens and why. So welcome back. Before we do the big reveal and say what actually happened, let's step through and see if we can predict it. Okay, so stepping through the code means we have to run together through the main method, and we're going to pretend to be the computers running this code. Okay, so the first thing that we have to do is we're declaring the variable coords, and so using our memory models, that means that we need to write the word coords next to a box in the scope of the main method. And what we want in that box is a reference to a new array that is initialized to the values 5.0 in index 0 and 0.0 in index 1. Okay, so the coords variable is in main's scope, and the array object that we created is in the heap. And so what's stored in the box for coords is a reference to the array. Okay. What's important here, what's important to keep in mind, is that an array is not a primitive type, it's an object type. Okay, so far, here's our memory model, and we've gone through one line of code. Now we get to the line of code that we will spend the most time on, and this is when we now declare the variable accra, and this variable is going to be of type array location, which means that what we want to do is, still in our main's scope, draw a box with accra, and what we're going to fill in there is a reference to an object. But in order to refer to an object needs to be constructed, and that's what that keyword new is doing. It's saying, hey, I want a new object, and the kind of object that I want is the array locations object. And so I have to go to the array location class and see that in the heap I'm going to have an array location instance, and the instance variables associated with that array location instance, well, they're listed right there in the class definition, and I need a coords variable. And now I'm going to go ahead and follow the constructor to initialize the variables in the instance that I have of the object that I have of type array location. So in the constructor's scope, I have another variable that's called coords, and that's my local variable for the constructor method that is the parameter to that constructor method. So the constructor array location has as a parameter a variable that's called coords. And what we do in this constructor, going back, before we go ahead and see what's in the meat of the constructor, we have to see what the value of that parameter is. So let's think about what's passed into the array location constructor when we were in the main method. When we were in the main method, what we passed into array location is coords. Too many coords! We can take care of it. We know what to do by looking at the memory models. The coords that's a parameter to the constructor is the variable in main's scope. And so the red arrow is what needs to be copied into the value of the variable in the constructor's scope. And so now the constructor's scope coords variable also points to the variable, to the array that we had in the heap. All right, so when we call the array location constructor, what we're doing is we're creating a new scope for the constructor. We've got a variable in there that is the parameter to that method, and that variable is initialized to the value that was passed in, which is a reference to the array in the heap. Okay, so now we need to remember one more thing when we have a constructor, and that is that we want a variable as well in the constructor's scope called this. And what this does is point to the location in the heap where we've allocated space for the object that we're creating. And remember that when we finish with a constructor, what we'll be returning to main is that reference to the object that we've just made and initialized. Okay, so here's our picture so far. And now let's figure out what's happening when we actually execute the code in the array location constructor and try to initialize the variables in the object that we've created. So the one line of code in that constructor is an assignment, this.coords equals coords. So what we're trying to do is we're trying to assign the value on the right-hand side to the thing on the left-hand side. And so on the right-hand side, we just have coords, but we're in the constructor's scope, so that variable is the circled variable coords that has that red reference. It's pointing to the array in the heap. And what we're doing is we're copying that reference to this dot coords. So remember, when we have a dot, that means that we can find the variable by following the arrows. So we look at where this points to, and this points to the object of type array location in the heap. And what we're doing is we're setting the value of the variable coords in that object scope. So this dot coords, that variable in the heap that belongs to the object, is going to now point to the array in the heap that was pointed to also by coords in the constructor scope. So we have all of these arrows, references pointing to the same array, but notice that we're still missing one, we've got one box empty. And so we're going to want to fill in that box, but we're going to be able to do that. And let's think about that, how that happens. So let's think about what's going to happen now that we've executed the one line of code in the constructor and finished with the constructor. So we're done the constructor, and what happens now is that the reference that was contained in this variable in the constructor gets copied into the variable that gets assigned the new object. Okay, so that yellow arrow is now allowing the variable accra to point to the object that we created in the heap. But also we have to do a couple of things when we finish executing the constructor. We notice also that once the method finishes and returns its value, its scope goes away, and all variables associated with it just go away. And so we can erase it from our memory model. We don't need to think about it anymore. Okay, so we finished our our constructor. Our memory model is now a little bit cleaner, and we have in our mains scope a couple of variables, and they point to a couple of things in the heap. And so now let's think about what happens as we continue executing the main method. So we go ahead and we try to set the value of at the first position in the coords array, so at index 0, and we're setting it to 32.9. And so what we're doing is we're saying, let's look at coords in mains scope, and we're setting the value at the first position there to 32.9. Cool, we can do that. Similarly, we look at that same reference to the same array, and we change its second position at index 1. Cool, we did that. But now, let's think about what happens when we print accra.coords, its value at its index 0. And so when we think about that number, well, we need to find it by following the arrows. So we go to the variable accra, and it's got a reference. And so when we say accra.coords, we want to follow the reference from accra all the way over to its object and look at the variable in that object scope, coords. And that coords is also pointing to the same array that we had in the heap. And so notice that what we get output is 32.9. Okay, pause and think. There's something weird happening, right? We wanted to store in the accra object the coordinates of accra. But then we were able to do something outside that object without any setter methods, without going into the variables of that object. And without doing that, we were able to change the value of the instance variables in that object. And that is not a good thing. So this is what happens when we're too loose about using object type variables as opposed to primitive type variables. They can change on us without us intending to have them change. And so the moral of this example is A, memory models help us in actually tracing through code and figuring out what happens. And B, when we have objects and basically object types which include arrays, something that's not primitive, then we really have to worry about what is allowed to refer to that object and how can its values change in perhaps unintended ways. Okay, so hopefully you feel like you can do this yourself as well with any example that's thrown at you. This is a tricky one, so if you need to go back and look at it again, do. But now you're ready to go continuing on with this module and beyond.
congratulations on getting Java, Eclipse, and Unfolding Maps set up on your system. Getting that set up is actually one of the biggest barriers to getting started with this course. So now that you've gotten that done, we can start diving into the programming projects, which we hope will be more fun. The role of these videos is first to give you an idea of what's required for the project, and secondly to give you some hints about where you should look at in the code to help solve the problem. So this video is really a high-level view of the programming assignment along with some tips. If you want the full details of the assignment, you can always go to the reading on the programming assignment. So for now, let's dive into the code. So if you got Unfolding Maps set up properly, you should have a package here which is UCSD Unfolding Maps. And let's start by expanding that. So expand it. Go into the source. Module 1 is for this programming project. Go into Module 1, you'll find Hello World. If you open that, you'll find this file here. Now, it's always a good idea when starting with a new file to figure out what the high-level structure is. So we know what the class name is. This is Hello World. It's extending papplet. We're going to dive into some details about what extends means later in this course, but for right now, this means that this is going to be a graphical user interface. And it has two methods that we're going to care about. So if you scroll down, you're going to find the setup method. Setup is called once, and it sets up everything within the frame. And then the other method that we're going to focus on is draw. Now draw is called repeatedly. So now that we have an overview of the structure, that there's a setup and a draw method, let's try running the application and see what it looks like. So go under here, do run as Java applet. And what we get is an application that has a background with a map on it, and this map is zoomed into California. It already has some built-in functionality in that you can zoom in or zoom out if you wish. And what's missing from this right now is a second map, which should go here, which is going to be zoomed into your hometown. So that's the main thing you have to do with this assignment, is create the second map that's zoomed into your hometown. And what we'll do is we'll start looking at the code that might help you accomplish this. So the main thing to focus on is, where was that first map created? So if you go into your code, what you'll find are we have two maps that are created, map 1 and map 2. And before I dive into the details of those, I do want to mention, if you are working offline, you'll want to change this variable to be true. All right, back to our maps. So we have two maps, an unfolding map 1 and unfolding map 2. And what we've set up is map 1 for you, but we haven't set up map 2 yet. We create the application just as we do here, which is using the size method, which creates an 800 by 600 size map. And then we set the background. If you want to change the background color, you can play with that here. And then we use our map provider, which here we are using Google. We have some code which only applies if you're offline. And then you can find down here finally our first use of map 1. Here we're creating a new unfolding map. Here's our X, our Y, our width, and our size. And we're using this Google Map Provider to create this unfolding map. Now you'll want to use something just like this for your solution. And notice that then, right after we create the map, we then zoom and pan to a location. And this location happens to be the location of UCSD, but you'll want to put in the location of your hometown here. The next step is to see if map 1 is used anywhere else. And it turns out map 1 is shown in the draw method. So as long as you do the draw method if you call map1.draw within the draw method, map 1 draws. You'll want to do something similar with map 2. So I hope at this point you have a pretty good feel of what you're going to do. So you're going to focus on setting up a map 2 at the right location in the application, and then you're going to zoom into your hometown, and then you're going to make sure that map 2 is drawing every time this draw method gets called. After completing your assignment, your next step will be to just take the programming assignment quiz at the end of this module. So you will not be sending any code for any of the assignments within this course. Instead, you'll be taking the end of module quizzes, which will test you in the concepts both in the module but also on ideas related to the programming assignment. So before you take the end of week required quizzes, make sure you do the programming assignments first. All right, good luck on this assignment. I hope you have fun.
Hi, and welcome to the Coursera specialization in software design and architecture. I'm Ken Wong. It's my goal to help you become an experienced software architect who thinks critically about the design and architecture of your products in order to create great software. I'll be doing this with the help of our learning navigator, Sam Jeffrey. You'll meet her in a moment. You have probably already worked on some software projects in the past. Some of you may have worked on small programs, some of you may have worked on a larger scale system. Take a minute and think of the projects that you worked on. Did they have a good design? Could the design be done better? Was there even a design at all? How do you know if the software was well designed? Think about how easy it was to make changes to your code. Did a small code change produce a ripple effect for changes elsewhere in the code? Was your code hard to reuse? Was the software difficult to maintain after a release? If you answered yes to any of these questions, chances are you could have benefited from a better design. Good design isn't just about code. It's about being able to express ideas for your software with other developers, other teams, and your clients. Having a well-thought design makes your software easier to implement, reduces the need for major changes later in the project, and saves you from headaches down the line. Whether you're a new developer looking to expand your knowledge, or an experienced industry veteran, knowledge of software design and architecture will help your software become flexible, reusable, and maintainable.
Hi, and welcome to the Coursera specialization on software design and architecture. I'm Sam Jeffrey, your learning navigator through this specialization. It's my goal to help you become an experienced software architect who thinks critically about the design and architecture of your products in order to create great software. So, what is software design and architecture? How does it improve your software products? Consider this scenario. You join a project that's been in development for a while. You look at the code and become instantly overwhelmed. You can't tell what the purpose of the pieces are, things are unorganized, and design documentation is non-existent. You don't even know where to begin. These are all signs that the project was not well designed from the outset. Or let's say that you are now working on a personal development project. When you began, you weren't quite sure what the functionalities would be, but you just started coding. It didn't matter that the code was unorganized because you were the only one working on it, and you know how it works. You come up with a great new feature for your product, but in implementing it, you broke the program elsewhere. You should have designed it right. I'm guessing that you have experienced scenarios like these. They are quite common in the software industry, which shows you why software design and architecture is so beneficial. In this specialization, you will learn how to apply design principles, patterns, and architectures to create reusable and flexible software applications and systems. You will learn how to express and document the design and architecture of a software system using a visual notation. We will give you lots of practical examples and opportunities for you to apply this knowledge so that you leave this specialization with employable skills and relevant knowledge to confidently work in the software industry. It's important to note that this specialization primarily covers software design and not user interface design. Although the two aspects of design are closely related, we will mostly focus on software design. We have tried to align our course with the ACM IEEE Software Engineering Curriculum Guidelines. It recommends the topics when teaching software design and architecture. However, with that being said, this specialization has no affiliation with ACM or IEEE. I provided a reference to these guidelines in the course resources if you'd like to read more about it. This specialization consists of 4 courses. Each course features 4 modules, with the first 3 focused on content and initial parts of the capstone project, and the 4th to complete the rest of the capstone project. The capstone projects will give you the opportunity to apply the knowledge that you learn in each course to a real, functional software product. In the first course, you will learn about object-oriented design. This course will build upon the basics of Java and take you to the next level by covering object-oriented analysis and design. You will discover how to create flexible, reusable, and maintainable software by applying object-oriented design principles. You will learn how to communicate these designs by expressing them in a visual notation known as Unified Modeling Language, or UML. In the first capstone project, you will be challenged to apply your knowledge of object-oriented design by evolving and documenting a Java codebase with corresponding UML documentation. The second course focuses on design patterns. Design issues and applications can be resolved through design patterns commonly applied by experts. The second course extends your knowledge of object-oriented analysis and design by covering design patterns used in interactive applications. Through a survey of established design patterns, you will gain a foundation for more complex software applications. Finally, you will learn how to identify problematic software designs by referencing a catalog of code smells. In the second capstone project, you will be challenged to redesign an application to use design patterns. The third course covers software architecture. By the third course, you will be equipped with software design patterns and principles, and will be ready to learn how architecture can be used as a basis for organizing the software systems found in industry today. Through a review of architectural styles, you will explore the structure and behavior of large-scale software systems. Specific UML diagrams will express important architectural perspectives. You will learn how to analyze and evaluate a given architecture by examining the trade-offs between competing quality attributes, such as modifiability and performance. In the capstone project in this course, you will document and evaluate the architecture of a layered Java system. Finally, in our fourth course, you will learn about service-oriented architecture. Based on the understanding of architectural styles that you learned in the third course, you will review architectures for web applications. You will then explore the basics of service-oriented architecture, or SOA, in two approaches, web services and representational state transfer, or REST, architecture. In the final capstone project, you will connect a mobile application with a variety of REST interfaces to access storage, search, and computation services. By the end of the specialization, you'll know how to design it right. Our courses are designed to be taken in sequential order. However, the courses do stand alone. If there was a specific area of software design and architecture that you were interested in learning about, you could just take that course. In this introductory course, and throughout the specialization, we will assume that you possess basic Java programming knowledge. In this module, there is a Java pretest that you can take to see if your Java programming skills are sufficient to succeed in the specialization. The pretest is not meant to discourage you from taking our specialization, but is intended to set you up for success by identifying areas that you may need to review before taking the specialization. We understand that our learners will come from various backgrounds and experience levels. In order to make sure that all our learners are on the same page, we have tried to be explicit when introducing new terms. Based on your experience level, you might find that you should complete additional readings to fully grasp the topics. Or, if you are an experienced developer, you may find that some topics you already know. In a specialization of this size, it's difficult to ensure the material is appropriate for everyone. We've done our best to provide you with the resources you need to understand the material. We've found that, even if you are an experienced developer, there's still a lot to learn, so we encourage you to engage with the lessons even if you've covered the material before. Who knows? Maybe the material has changed since you learned it. I also encourage experienced learners to share their expertise in the discussion forums. Let's build a strong community of mentorship and camaraderie. Well, I think you're ready to embark on this journey. So, once again, welcome to the Software Design and Architecture Specialization brought to you, in partnership, by the University of Alberta and Coursera. I hope you enjoy it, and I wish you the best of luck. What does a career in software design and architecture look like? What is the difference between software design and software architecture? These are questions that we will explore in more detail throughout the specialization. However, let's take a quick look at them now. Like many roles in the software industry, the software designer or software architect role can look very different from company to company. Characteristics like company size, the scope of the project, the experience of the development team, the organizational structure, and the age of the company can all impact what these roles look like. In some companies, there may be a distinct role for a software designer or architect. In other companies, the design may be completed by a member or members of the development team. Typically, the software designer role would be responsible for outlining a software solution to a specific problem by designing the details of individual components and their responsibilities. A software architect role would be responsible for looking at the entire system and choosing appropriate frameworks, data storage solutions, and determining how components interact with each other. That brings us to the primary difference between software design and software architecture. In short, software design looks at the lower level aspects of a system, where the bigger picture, the higher level aspects of a system. Think of this like designing a building. An architect focuses on the major structures and services, while an interior designer focuses on the smaller spaces within.
Great software designers and architects are detail-oriented, forward thinkers. They need to be able to see the product at both the low and high levels. They need to be creative problem solvers in order to come up with a quality solution for the problem at hand. And they need to be able to express these ideas effectively with the product manager and the development team. Does that sound like something you'd be good at? Software design and architecture is essential to the software development process. Let's take a look at what people in the industry feel about this role.
Software design is the process of turning the wishes and requirements of a customer into working code that is stable and maintainable in the long run and can be evolved and can become part of a larger system. That's software design.
I like the or because I don't make a distinction between software architecture and software design. I think they're just the same problem at a different scale. The way I like to think of it is that architecture is primarily begins with understanding what's the business problem that the client needs to solve. Where business, it doesn't mean necessarily financial business, any business. Once you've realized that that's your primary task, which is to figure out what the client wants, then everything kind of falls in after that. Because if you understand the problem, then you can start to think about what in your previous experience is possible solutions, and then you start getting an idea of how your overall solution is going to look like. And that's where I kind of say, really, architecture is the study of boxes and lines. Because your first description of what it is you're trying to do is simply a set of boxes with things inside them and lines expressing relationships.
Design and architecture is important if you want to have a stable, long-lived system. Anybody can build a system that'll last a week or a month or a year, but if you want to build something that is the basis of other people's work and contribution over potentially a period of years or longer, in some cases, you need to put some thought into it. You need to have somebody whose job it is to look out for the long game and make sure that you're not making suboptimal short-term decisions.
Architecture is important because if you get it wrong, your project will fail. That's it. It's just that simple. We know it in the building world, we know it in the software world. Where we're using the term architecture to be this understanding of the relationship between the requirements of the user and the ability to build a system that will deliver those requirements. I think you can trace back most major software failures to bad architecture, where architecture is used in this general sense.
One of the key challenges in software architecture is the tendency to have to trade off between speed and quality. If I boil it down, right? I think there's a tendency for the customer and the business to want their software, to want their results as soon as possible, and there's a tendency for the engineering team to want to build, the most robust, thoroughly designed, thoroughly implemented system possible. And so we're trading off between these things all the time. And I think it's that tension and that trade-off is where you get really good software, you get good designs out of that, but it's a process you have to go through to go through that, yeah.
So our biggest issue that we face is understanding the client's problem. What is it they really want to do? And in many cases, the client actually doesn't know what they want to do either. They come in with only a partial understanding, a vague kind of sense that they could be doing things better. But often one of our first tasks is to actually help them understand with more precision what their business is.
A software architect's job is to be the interface between the product and the customer and the engineering teams. And so, for instance, customers will express a requirement or a need that they have of the software, and it's the architect's job to then work with the customers and their representatives, product managers and such, to come up with the technical requirements of how we're going to solve the problem. And then they take those requirements to the engineering teams and work with the engineers on how to realize that in a way that is meeting the customer's requirements and also aligned with the technical best practices and non-functional requirements that have to be adhered to in the product.
The software architect is like a building architect. They're responsible for the overall conceptual integrity of the project. Their main goal is to serve the needs of the customer within the budget that the customer has.
I would express software design or software architecture in a couple of different ways. For small things, for simple things, you'll sit with an engineer and you'll whiteboard something out and you'll come up with a design that way and you'll basically get them going. For larger initiatives, larger projects, you're typically writing fairly substantial design specification documents where you're exploring all the different possible use cases, all the different possible flow variations and things of this kind, in addition to all of those critical functional and non-functional requirements, stability, maintainability, these kinds of things. So in general, I would say that we communicate software architecture through the written word, through wikis, through white papers, these kinds of things, in addition to fairly detailed engineering design schematics, class diagrams if necessary, big box diagrams if it's just a simple high-level architecture design.
I've been programming for 45 years. And one thing I've learned is that the only thing that's really there is the code. And everything else that you talk about is views on the code. So I like to express architecture or describe architecture as saying that all the things that I'm going to do, the boxes and lines, the prose, the fancy diagrams or the diagrams on napkins, they're simply indexes into the code. That's how you find your way to the actual artifact that's actually doing what you want to do.
I tend to apply simplicity first as my main principle. If I'm looking at how I'm approaching the problem, that's the filter that I try to use on it. And I often will find myself, I think there's a tendency in people to complicate things, to inject complexity because it's interesting. As an engineer, as a technical person, complexity is fun and interesting. And it's only when you stripped away all the unnecessary complexity that you realize you've got the core of a great solution to a problem. And so I really try to do that. And when I'm working with product teams and engineers alike, that simplicity principle really helps to cut through a lot of the confusion.
What's the most important principle? Simplicity. That's true, and it's the engineering maxim too. Keep it simple. The reason for that is twofold. One is that if it's simple, you probably have a pretty good chance of getting it right, or almost right. That's one part. The other thing is if it's simple, then you can explain it to someone simply. That communication of architecture is important because you're not going to be around forever, and you need to transfer your knowledge over to someone else. And if it's not simple, the knowledge transfer cost is higher because it's more complicated to explain, and the chances of misunderstanding are much higher.
So I became interested in software design by working as an engineer and being exposed to larger scale code bases, progressively over the years. When I first started, of course, I worked on mostly fairly small things, and I was very interested in how software was put together and the design at kind of a micro design level. And then as I proceeded in my career and I started to be exposed to some fairly large pieces of software that serve, millions of people, I got really interested in how those things are put together and what is it that makes that successful, and how do you make sure that you're not having to re-implement this thing over and over and over again. And I found that to be a really interesting side of the business that I really hadn't explored before. And so it turns out I really enjoyed that.
I think if you start writing code to do things, to play around, you start asking yourself questions about, well, why is it that this code is really nice to work with and this code here is horrible? And you start asking yourselves questions about design. And the difference between design and architecture in the software business is there really isn't any, because our business is all self-similar. Issues that you ask about programs are the same issues you can ask about big systems. And I think in my case, I just became interested in this fundamental understanding of the issue of building software artifacts, and then it just naturally scales up. At some point, you're building systems with 100,000 lines of code. And then you suddenly realize on your project team that you now have 1 million lines of code. and you're now a software architect because you have 1 million lines of code, whereas before you were just a programmer because you only had 10,000 lines of code.
Most architects that I know started as software engineers, usually, as an intern or a new grad, and they work basically over time. They work on progressively larger and larger pieces of the software that they're responsible for. And what happens is you start to see those engineers get to a level of comfort where they start to push outside of the code base that they're directly responsible for, and they start involving themselves in discussions around the larger impacts to the system of the work that's being done. And that just generally continues until all of a sudden they're actually working at a much higher level of abstraction, and then contributing at a very different level. And so that's how you've got an architect on your hands.
Yeah, there's not a career path into software architecture. What it really is if you think of architects as having more responsibility than programmers, what it really is a career path where you get more and more responsibility. That you do by demonstrating that you're actually good at building things. My experience has been that I didn't think I was an expert programmer until I had been out in the world for 10 years. And I think that's consistent with many of my colleagues. Over that period, you start working on bigger and bigger systems, and eventually someone trusts you with being the point person to put together the design for a much larger system than you'd ever done before. And then once you've done one of those and it hasn't been a total disaster, you get an even bigger system. So I guess it's gradual building of your reputation is what makes you into a software architect.
I would say the most exciting thing about being a software architect is the satisfaction of seeing the final product put together and out there and being used by real people to good effect, right? So because you spend all this time early on in the project, and you have to fight for your non-functional requirements, and you have to fight for how this is all going to be put together. And then when it all comes together and you've done all that negotiation and it's out there in the hands of a customer and it's valuable, there's a real sense of pride with that. I think additionally, you also get a lot of satisfaction and pride from making the right call in terms of long-term viability of a code base and of a project. And so seeing somebody be able to come to your product maybe years later and make some very business critical contribution and extension of something that you designed without having to redesign it is very satisfying. It tells you that you hit it on the right mark.
What's exciting in architecture? Well, in general, you don't want too much excitement, because that's usually associated with some sort of looming disaster. But what's interesting about software architecture, and that continues to make it interesting, is that someone always has a problem that's slightly different than all the problems you've seen before, which means that your previous solutions aren't necessarily going to work, and you get to do something new. So it's the novelty that makes software architecture interesting.
An architect has to have a number of important skills. Obviously, deep technical expertise is table stakes. You have to be a technical guru, I think, at a certain level. In addition to that, you need to be able to communicate with people at the level that they want to be communicated with. So if you're talking to a business person, they don't want to hear about your code. They want to hear about their business problems, and they want to hear how you're solving their business problems. If you're talking to an engineer, they want to know the business context, but they need you to be able to talk to them about code. And so it's really important to have that ability to understand how the person you're talking to wants to be communicated with. So empathic communication, I would say, is really important. Additionally, some basic functional skills like a little bit of project planning and organizational skills, being able to keep a backlog of work so that you don't forget about things, being able to juggle a lot of different competing concerns at the same time is also a very important skill.
The most important ones are what I would call the soft people skills that you need in order to get people to tell you what the requirements are. This is very hard, actually, especially in situations of uncertainty. Clients are very reluctant typically to tell you the things that they're really bad at. They like to tell you all the things that they know how to do, but they're reluctant to express where their understanding of a problem is incomplete, or where their business processes just don't work right. And if you don't identify those areas, you've actually encountered a big risk in your project, because those are the areas that are the problem. The well understood parts of a client's needs they're not an issue. It's the parts that are fuzzy and not well understood. But of all the technical skills that you've got, you need this meta skill, which is to look at various technologies and ideas and decide, is that going to be useful to me or not in my particular problem I'm trying to solve? So as an architect, you have to know a lot about what's out there, but not in a tremendous amount of detail, because a lot of the stuff that's out there isn't going to be useful to you, at least immediately. And by the time you might need it, it's probably gone through 10 releases anyway and isn't the same thing. So you have to have this skill of being able to quickly assess various technologies and fit them into your understanding of the discipline. So a new language comes out, you sort of say, oh yeah, this is yet another procedural language with nothing much different than all these other ones. Or you might see something else that says, oh, that's interesting. I wonder if this particular style of approaching the problem, perhaps aspect-oriented programming, just to pull something out of the air, will actually help me solve my problem in a better way, or express my problem in a better way.
Well, staying up to date is a bit of a trick. It's about exposing yourself to as much as you can in the outside world and inside your own company as well. But in particular, look at what the big companies are doing. What's Apple doing? What's Google doing? What's Amazon doing? And you read their blogs, you play with their software, you get an account on whichever tool you want to use, and you start using those things. And you use that for inspiration and just to see how others are approaching architecture in their systems, right? So there's a number of levels of inspiration there, I think. Additionally, read a lot of just the general tech press and find out what's going on out there in the world. Read academic journals for the appropriate areas and see what's coming a little farther down the line. What are the academics thinking about? So there's lots of those things to go after. So the advice I would give to a new software architect is to get as comfortable talking to people as you can and meet as many people as humanly possible. Expose yourself to as many ideas as you can and share your own perspective as well. And I think it's by leveraging the community, leveraging those around you, that you're going to be inspired to be creative in your architecture, and you're going to get a better understanding of the context in which you're operating, both within your business as well as the broader technology landscape out there. And it'll help you to make better choices, ultimately.
The advice you give to a new software architect is the same advice you give to a musician. Try and play with people who are much better than you are, because that's how you become a better architect. And that means working with people who are better than you are, if you have the opportunity. At the very least, trying to read as much of the foundational literature in the field. And there's not that much to read. There's maybe 20 key resources you should go to. Some of them dating back to the original papers in the 70s about coupling and cohesion. And then, of course, writing code. So you need to work with people that are better than you are, read a lot of code, and write a lot of code. And that's how you become a software architect. Oh, and of course, learning from your mistakes is also quite valuable.
you may have heard the term object-oriented modeling. You may have even applied it, whether you knew it or not. Object-oriented modeling is a major topic in this specialization. So what is it? When solving a problem, object-oriented modeling involves the practice of representing key concepts through objects in your software. Depending on the problem, many concepts, even instances of people, places, or things, become distinct objects in the software. Think in terms of objects. Objects are all around you. Take a look around. What do you see? I'm guessing you see a computer or tablet. You may also see other physical objects like a table, a door, or a coffee mug. Is there anyone else in the room? They are objects as well. The room itself is even an object. So why should you use objects to represent things in your code? It is a way of keeping your code organized, flexible, and reusable. It keeps code organized by having related details and specific functions in distinct, easy-to-find places. This creates flexibility because you can easily change details in a modular way without affecting the rest of the code. You can also reuse code and keep your programs simple. Let's explore what object-oriented modeling might look like. Consider the seminar room, for example. The first object we identify is the room itself. The room has details such as the room number and the seating capacity of the room. We can also identify objects that are contained within this room. What are some of these objects? Have a look around this room. There are many physical objects such as the chair, the table, the projector, and the whiteboard. Each of these physical objects could be represented by objects in software. There are specific details associated with each object. The projector has specs related to its performance, such as resolution and brightness. A chair has its own details, such as seat dimensions, that would be relevant to a user of that object. Objects can also have individual responsibilities or behaviors. For example, the projector is responsible to power on, take a video input, and display an image. What about a person as an object? That works too. Let's put a person object in this room. A person object would have details such as name, age, gender, and occupation. There are also countless behaviors that a person object could complete. In this example, Ken could write on the whiteboard, turn on the projector, sit in a chair, or open his laptop on the table. It's easy to think about people or electronics knowing about their information when achieving behaviors. For example, a person object knows their name and age, and a laptop knows its specs. In object-oriented modeling, even inanimate objects know their information. So, a chair knows its dimensions and location. A door knows its frame height and the angle that the door is ajar. The whiteboard knows its height and width, as well as if it's blank or contains writing. With object-oriented thinking, you often think of everything as objects, even living things. And all these objects are self-aware, even inanimate things. Object-oriented modeling will be a major topic of the work that you do in this specialization. Start viewing the world around you in terms of objects. It will help you out when you're called upon to design software using object-oriented modeling. Think objects.
ディスコンネクト